Hi everyone. We're going to wrap up our lesson from 8.1 really quickly. So we left off working through this example where we're asked to find the length of the semi-cubical parabola. Y squared is equal to x cubed between 1, 1 and the 0.48. And then we set up integrals to compute arc length both with respect to x and with respect to y. So we're going to go ahead and work out this arc length with respect to x by hand. So arc length in terms of x, we said was the integral from 1 to 4. And then I'm going to take the square root of 1 plus, when I square 3 rad x over 2, that's going to become 9x over 4, which we're integrating with respect to x. And then to evaluate this integral, we have to do so by using u substitution. So we're going to let u equal equal the inner function in the composition, 1 plus 9x over 4. When we differentiate, we get du equal to 9 over 4 dx, which makes dx equal to 4 over 9 du. Okay, so when I rewrite this arc length formula, I'm going to write my limits of integration and my function in terms of u and du only. So when I input the limits of integration into this function here, when I plug 1 in, we're going to get 1 plus 9 over 4, which is 13 over 4. And then when I plug 4 in, we're going to get 1 plus 36 over 4, which is 1 plus 9, which makes the upper limit 10. The function that I'm integrating becomes rad u, which I'm going to rewrite as u to the 1/2 power. And then we're going to replace dx with 4/9 du. Okay, so arc length in terms of x, I'm going to pull 4/9 out front. Antiderivative of u to the 1/2 is u to the 3/2 divided by 3/2. So dividing by 3/2 is the same thing as multiplying by 2/3. This is u to the 3/2 power, which we're going to evaluate at 13 over 4 and 10. So I'm going to multiply out front. We get 8 over 27. 10 to the 3/2 power is like saying the square root of 10 cubed, which is 10 rad 10 minus 13 over 4 to the 3/2 power. That's like taking the square root of 13 over 4, which is rad 13 over 2, and then cubing that result. So whenever we cube that, the numerator is going to become 13 rad 13. The denominator is going to wind up becoming 2 cubed, which is 8. Okay, and that right there is the value for the arc length. Okay, so we'll move on to the last example, where the directions here just ask us to set up an integral that calculates the length of the arc of the hyperbola x times y is equal to 1 from the point 1, 1 to the point 2, 1/2. Okay, so I don't think it really matters in this particular case whether we set this up in terms of x or in terms of y. I'm going to do so in terms of x. So I can say that when I solve this equation for x, we get y equal to 1 over x, or x to the negative 1 power. When I differentiate that, we get y prime equal to negative 1 x to the negative 2 power, or negative 1 over x squared. Okay, so if we're going to write arc length in terms of x, that's going to be equal to the integral from when I look at these 2 points here, I want to determine the x coordinates of those 2 points, which are 1 and 2 respectively. And then we're going to integrate the square root of 1 plus dy over dx, which is negative 1 over x squared, quantity squared, which we're integrating with respect to x. So I'm just going to simplify this just a touch. So this is going to become the square root of 1 plus negative 1 over x squared becomes 1 over x to the 4th power. You can leave things in that form. If you want to combine into a single fraction, you can do that as well. So that becomes the integral from 1 to 2 of x to the 4th power plus 1 over x to the 4th power, which we're integrating with respect to x. And I think that's acceptable as far as excuse me, our integrand goes. Okay, so that's it. That's going to wrap up section 8-1, and that wraps up our unit on chapter 7 and 8. So this is going to be the cutoff for your guys' next exam.